model that has a lot to do with, I think, what a diet can do, among many other things. And this is a paper that came out in 2003 by Rubenstein and Merzenich from San Francisco, UC San Francisco. The title was Model of Autism, and I'm going to explain what this means. Increased ratio of excitation inhibition in key neural systems. All right, so you've got, this is a fraction, right? So you got the numerator, you got the denominator. And remember from arithmetic that if the numerator goes up, it gets bigger, and if the denominator gets smaller, it gets bigger. So if you get more excitation, the whole thing's going to be bigger. So you get more excitation. And if you have less inhibition, the whole thing's going to get bigger. So what gets bigger is the irritability, the hypersensitivity, the excitability, the reactivity of the brain. And what I think the diet people are arguing is that diet can affect how excitable your brain is. Diet, a lot of things can, diet toxics. This increased irritability, hypersensitivity, overload coming from this ratio, and there are many things that can increase the numerator or decrease the denominators. This is another final common pathway, like I was telling you. And the authors took pains to point out, number one, that there are many ways you can mess this up, and number two, that this implies treatment because anything you could do to reduce the excitation or allow the brain to perform its normal inhibition again would help improve function in real time. Not genetic engineering. It's something much simpler than that. This kind of increased excitation inhibition can explain such features as sensory, just not being able to stand the light or the sound or the labels of the clothes. The sleep, the just being too unable to calm down and sleep, the seizures, the epilepsy, and some of the diarrhea and gut motility issues, among other things. Inflammation and oxidative stress are well known to create changes which increase excitation and change the ratio. Now, excitotoxicity, there's a guy named Russell Blaylock who's recently written 2 papers on excitotoxicity in autism. If you go to literature, people talk about excitotoxic cell death. But I want to say that that's a little radical, that you don't have either the cell is fine or it's dead. It's a process. So the end result may be at some point you arrive at cell death and cell loss. But that's not the first thing that happens. The first thing that happens is, before that you have stress and oxidative stress, and before that you just have too much excitation going on. The receptors are too responsive. It starts out small and it builds. And I think that's where the dietary and lifestyle interventions come in, is that you're trying to say, we're going to get into the parts of this process that aren't over the edge, that there are things that are still happening and we can make it get better rather than worse. And I think that that's, at the scientific level, the rationale for changing the metabolism of the person with autism, and I would say this is actually true for everybody, in one way or another, so that you're more even-keeled and more balanced in this excitation-inhibition ratio. That's what I said here. While it's a process, there are things that you can do. So this leads to a different model of autism. Instead of saying that autism is an altered brain wiring diagram caused by genes, that's immutable, autism could be considered a consequence of challenges to cellular function throughout the body, including the brain. These challenges may be related to environmental insults, and that can be anything from toxins to lousy food to, radiation to noise and stress to a lot of things. Just poor living habits, stress of many different kinds. Altered cellular response could be at the root of brain and body problems, and many cellular problems can be treated and prevented and ameliorated. So this model leads to an approach where you really want to do things that are good for your cells. And I think that that's what the specific carbohydrate diet is about, among other things. But that's what the underlying rationale is. So it's not like you're beating your head against a hopeless genetic thing, that even that model of hopeless genetic is not the way things are. So this is the hopeless genetic model that I showed you before. And the implications are it's genetic, it's hopeless, nothing's going to change, and so forth. And I'm talking about a different kind of model where you've got genes, sure, you've also got environment, you've got alterations even when you don't change the genes. In epigenetics, what gets turned on and what gets turned off. And also environment can mess up your genes. They can mutate your genes. Some of the genetic research is showing that many children with autism have mutations that they didn't get from their parents. The parents don't have the same mutations. So something went awry somewhere between the parents and the kids, either in the parents' germ cells or during pregnancy. So you've got these inputs, genes, environment, and genes turning on and off. This dysregulates your cells and your biology all over the place, not just your brain. That means that the molecules are not signaling each other properly, your sensory system is not picking up signals properly, and your brain anatomy can be is also affected, and these two things aggravate each other. At the medical body level, you see sleep problems, sensory motor problems, epilepsy, body problems like the gut. Some kids with autism even have osteoporosis or thin bones. Interestingly, some of my mainstream medical colleagues wanted to use that to prove that children with autism are not drinking enough milk. And then this quote-unquote crazy gluten-free, casein-free diet, that's the reason. And so I go to the literature and I put in inflammation, osteopenia, which is a milder version when your bones are starting to get, I had like 550 papers. It's very well known that gut inflammation is bad for your bones. It's just known. It just doesn't happen to be known in autism, but it's known everywhere else, or in a lot of other places. So this is one of the problems that you have, is that people, and also there, by the way, that I mean, I don't drink milk, so I think about this a lot, and I like milk. But there are cultures over the world that people don't drink milk after infancy and childhood. There's nothing sacred about drinking cow's milk all your life. I went to China, I couldn't get milk. I felt a little bit, but not really. The food didn't have it, and people were doing fine. They got all kinds of other ways of getting their nutrients. So you have these sleep, sensory motor, epilepsy, somatic issues. What we see as social beings with the unaided eye is the output from a brain that's working differently because of different cellular function. Communication, social interaction, and behavior, flexible behavior, require an extraordinary amount of brain coordination that's very precisely timed. If you've got sluggish cells, and then these astroglial cells, they push the neuron, they make the glutathione, they monitor the glutamate, which is excitatory. If they can't do the glutathione-glutamate thing properly, right there, the neurons are going to have all kinds of detox and excitatory problems. Right there, I personally think that these astroglial cells are going to turn out to be really huge in autism. They can explain most of the brain stuff very well. So the cells act differently, and then you get different behaviors. Big surprise. But that doesn't mean that that's what's causing it. That doesn't mean that's the core essence. That's the output of a system that from the very cellular level is not working right. Those behaviors are a pain in the neck a lot of times, and you need to deal with them. But even better is to assist the struggling system to not have to struggle so hard and to be able to spontaneously produce more richly integrated activity.